And as a result, well, we need to darken this up too. That helps. And where did I put my golf ball? There it is. So as you're moving along, something like the golf ball here, throwing it up, you can see it at different instances of time. The balloon moves much more slowly, so it almost looks naturally falling. If I take my oscillator here, notice you're catching at certain instance of time, or snapshots. And finally, the last one that's always kind of nice, if I can find it in the dark here, is my umbrella. And start rotating it slowly first, and speed it up, and speed it up. And at some point, what do you notice? Anything?
Going backwards.
Okay, look like it's going backwards?
Yeah.
If you watch TV shows and you see cars' wheels running backwards, it's because the rotation rate of the wheels compared to the capture of the image from the camera is out of sync, and it actually makes it look like it's running backwards. As I bring it to a halt, that's it. I'm just going to start mixing it in. Now it ends up that the creamer is a very small particle, and it ends up that that particle is going to preferentially scatter one color of light over another, just like a prism will preferentially refract blue light stronger than red light. And as I do this, what do you notice about the light that gets to the ceiling as I add more and more of the creamer? Okay? Put it a little bit stronger. And what's happening to the color now? What does this look like primarily over here, if you look actually at the bowl?
White.
It looks more whitish and maybe a tinge of blue to it. It ends up that this kind of scattering, which is called Rayleigh scattering, is why the sky is blue and the sunsets are red, is that as the light of the sun is going through our atmosphere, if it goes a long distance through the atmosphere, it will preferentially scatter blue out. So when we look up away from the sun, we see the blue light scattered down to us stronger than other colors of light. And at the sunset, the light of the sunset getting through to us directly from the sun is depleted of the blues, and therefore has most of the reds and the oranges present. The flame depends on what elements are present. So in this particular case, I have some sodium in a bottle. And we get primarily what color of flame? Kind of orangish yellow. This one is strontium. And we get a strong spray here out of the bottle. We get some red. And copper is going to get us. I am on. Now, the last thing, it ends up that the flame is having problems moving upward. It's bumping into cold air that's around it. It ends up that cold air is more dense, warm air is less dense, so the warm air dense, or the less dense air rises, the more dense air sinks, and if I preferentially spin the system, the cold air will get pushed to the sides of the screen, the less dense air will be concentrated towards the middle of the screen, and as a result, we get the following. And this is the basic principle behind tornadoes, dust devils, is that you have warm rising air. As it has some spin to it, if that spin tightens down, it very efficiently transmits the warm air upward, allowing the cold air to come in and replace it. And of course, if you have a hot surface, it will continue on. And this can also occur during forest fires. You can get some firestorm situations. With that, Dr. Hutchison, I'll turn it over to you.